Good afternoon, grade 12s and colleagues once more. This is part 3 of the videos that we are busy recording. That is part 3 of the examination preparation for grade 12s. And maybe as well as colleagues, we will be able to take something that will enhance our teaching. Sorry about the earlier cut. It was beyond our control. We just had a power cut, but nonetheless everything went well. So we were busy with chemical and physical properties. It's a section that forms part of the organic molecules. So because we are looking for getting learners ready, or learners to be ready, the idea is time does not allow us to be able to revise almost everything, but expose our learners or us as learners at which way can I be able to achieve maximum marks. So this revision plan that I compiled, it shows now the number of marks allocated as per exam guideline and the number of achievable marks in this particular section. So imagine if we can be able to achieve almost at 50% of everything, focusing now on these particular areas. It says somehow we should be able to achieve maximum marks. So I was in a position of saying the definitions are key, identify the different types of intermolecular forces and their strength. But I said before that, what physical and chemical properties am I looking at? So I am looking at boiling point, melting point, and vapor pressure. But because I am going to compare, I need now to know which factors influences the boiling point, melting point, and vapor pressure. So the first one was chain length, number of branches, and the functional group thereof. And I said now, if I am sitting in an exam, before I can answer any other question that has to do with physical and chemical properties, the first thing to do is to ensure that I know which factor am I being assessed on. Because now for me to be able to say the examiner is assessing me with a functional group, it means I must compare different functional groups. For me to say the examiner is asking me to compare in terms of chain length or how chain length influences these properties, then it means they must belong to the same homologous series. I set the same now for the number of branches to say they must belong to the same homologous series. But the challenge was, if they belong to the same homologous series and they belong to the same homologous series, what other element can I add to be certain, to be sure, to confirm that definitely this is chain length, definitely this is number of branches? That is where now I came up to say they should be now isomers of each other. So if they are isomers of each other, they must have now the same molecular mass. So if the molecular mass is the same, already it says somehow they should be isomers of each other. So if they are isomers of each other, it means the examiner is trying to ask me about the number of branches. If I get now a different molecular mass, then it says the examiner is asking me about chain length. So this is key. Why is it key? It's key because when I look at this question here, before trying to go into detail of what is being asked or what questions will follow, already me seeing at A having butane 1 all, B butane 2 all, already it says something about now what? They belong to the same homologous series. So if they belong to the same homologous series, the only thing now that is changing here is now their positional isomers of each other. When I look at B and C, they also belong to the same homologous series, but now the B and C are isomers of each other. Can you see that? So it means whatever the examiner is going to ask, it's clear for me to say, if I am going to compare A and B, then it has to do with something up along the lines of a functional group, but of which in this case it's complex somehow. But for B and C, definitely they are isomers of each other. So it means the examiner is going to ask me to say something about the number of branches. So that is how we analyze the question even before we know what is being asked or what is it that the examiner is trying to assess. So once when I look at the table or even the graph that will be given, once I am able to say what is it or which factor am I being assessed on, everything will become clear and easy for us to be able to get maximum marks, because you cannot be able to give reasons in terms of the strength of the intermolecular forces and so forth if you are unable now to do what? To know exactly which factor is being assessed. So let's look at this question and we'll just try to answer a few. It says there, is this a fair investigation, yes or no? Definitely it's not, because we have too many variables that are changing. If you check at A and B, the position of the functional group is changing, so it is the functional group thereof, but only the position. And then for B and C, we have branching, so that is the number of branching that is changing. So it becomes now an unfair investigation, because you are now comparing two different independent variables. So the question there is 3.2, give a reason for the answer. At 3.2, there is more than one independent variable. That is what I tried to explain earlier on. And then we further move on. It says now, fully explain the difference in the boiling points of B and C. B and C becomes a fair comparison because the position of the functional group is at carbon number 2. And also, they belong to the same homologous series. Do they have different molecular mass? No, they don't have a different molecular mass. They are just isomers of each other. So what is it that the examiner is asking me? The examiner is asking me to say something about the number of branches, or how the number of branches influence or affect the boiling point thereof. So that is the approach that we should be working on when we try to answer this. But remember, there's a specific way of answering. I will write it down here to say we must generate now bullets that accommodates the 3 marks. Don't write it in form of a paragraph, because the intention is there are specific things that we are looking for. One, we are looking at the surface area when we talk of number of branches and chain length. We are also looking at the strength of the intermolecular forces, and we are also looking at the energy needed to overcome the intermolecular forces. So that will be the key idea. So every time you reason, try to have your 3 bullets. I will add the 4th bullet only if I am comparing now functional groups. Why? Because for each functional group, I have now one different type of intermolecular force. But now that they belong to the same intermolecular force, it's very easy for me to say they have the same intermolecular forces, so there has to be a factor that makes the other one stronger than the other one. So when I look at butane 2-ol, butane 2-ol has a longer chain. So I will write here to say butane 2-ol, or compound A, to make it nice and easy. Compound A has a longer chain than compound B. Compound B has longer chain than compound C, because the question said we must compare B and C. Thereafter comes now to say, but what does this mean in terms of the strength of the intermolecular forces? So the longer the chain, the stronger the intermolecular forces. So I will be able to say now compound B has stronger intermolecular forces than compound C. Thereafter, more energy now is needed. It's needed to overcome, not to break, to overcome the intermolecular forces of compound. I must commit myself here to say it is for compound B. Hence, compound B has a higher boiling point than compound C. So this is what the examiner is looking for. The first one is what factor, and how does that factor now influence boiling point. So we have identified that to say the factor is the number of branches. So whatever you say here at bullet number 1 should be in relation to the number of branches. So you can easily say it is less branched, it is less compact, it is less spherical, has a longer chain, has a larger surface area. All those will be correct, because now the idea is we understand if it's the number of branches, it means it's either less branched or more branched. It's less compact, less spherical, has a longer chain. So it's easy for me to relate it with a longer chain, because I want in my lessons, in me remembering that I also have chain length. So if I know anything that has to say with to do with chain length, if there's a longer chain, there's a stronger intermolecular forces, so that I don't confuse myself in terms of exactly how to interpret the information that is given. Hence now butane 2-ol, or compound B, is less branched, less compact, less spherical, has a longer chain length, and then that will be now a mark for that. So at least we have that information. Thereafter, the examiner is looking at saying butane has stronger intermolecular forces, so stronger intermolecular forces. Even if we did not name them in this particular case, it does not really matter, because we are comparing compounds that belong to the same homologous series. But the ideal way of saying it's compound A and compound B and C have now strong hydrogen bonds, but compound B has stronger hydrogen bonds than compound C. So that is now if we are going to be specific in terms of what type of intermolecular force is present in compound B and C. Hence they say here identify the different types of intermolecular forces. So it will be advisable for us to say let's write them down fully. So it's easy for me to say compound B and C because they are alcohols, they have strong hydrogen bond. But compound B has stronger intermolecular forces than C. Then I will get now again another mark for that. Then more energy is needed to overcome the intermolecular forces of C. That will be another mark also for 3 marks. So this is now a pattern that we need to follow when we try and answer these particular questions. The idea thereof is have your bullets. In bullet number 1, check which factor is being assessed. Bullet number 2, compare the strength of intermolecular forces. Bullet number 3, say something about the energy that is needed now to overcome those intermolecular forces. I believe it's clear. So the idea is first check which factor is being assessed. So I gave you hints of what to look for. I gave you a crash course of what to look for. So once you are able to check if it's functional group, number of branches, the reasoning thereof follow suit. Then at 3.4, define the term positional isomer. Where does it come from also? It comes from the organic molecule. So you are given an organic molecule, you need to say something about the positional isomer. So the topics are interlinked with each other. So what I've learned in naming and structures can easily overlap to physical and chemical properties. So it means these pillars also, they now contribute into this particular topic. So defining a positional isomer, it will be easy for us to say is compounds with the same molecular formula but different positions of the functional group, and that will be your easy 2 marks. From A, B, C, choose the letter that represents each of the following positional isomer. Then the correct answer there should be A and B. They are positional isomers of each other. And then a tertiary alcohol. A tertiary alcohol, it should be C. Then C, the reason for C is that the carbon bonded to the functional group is bonded now to other 3 carbon atoms. So the best way is for you to know each and every definition, because now if you reason according to the way you think it's correct, it's not going to be correct, because the key idea is we are assessing whether you are able to give the correct definition of a tertiary alcohol. So it's easy to say now it is the carbon bonded to the functional group is bonded to 3 other carbon atoms. So if we check, it's 2 marks. So from what I have done, did I address or do I stand a better chance of getting now the achievable mark thereof? So when I look at this, I was intending to get around 7 marks. Then I have my 1, 2, 5, 7, 8, and then 10 thereof. So I'm even beyond the expectation. So if the questions allow you to get maximum, definitely we will go for maximum. But did I address the achievables? Yes, I did. So it means somehow the questions that follow as questions that I will attempt, but I have done majority of questions and I have saved myself time, so I will be able to understand and be able to answer the questions that follow. So remember, everything that we do should have a sequence somehow that we work with. It should have a pattern. So once we are happy with the pattern, that is now the learning, and you giving it back to us, it's a way that will assist you in terms of achieving maximum marks. So just go back, confirm if you are able to say something that has to do with number of branches. Go back, check now into the chain length as well as the functional group. I believe we have exhausted this particular concept, because the idea here for us is we only look at the achievables, which we call them low-lying fruits. So if you are able to perform that, then automatically everything will be into place, and then we'll get passing. So the other questions, yes, are important. We will not let them go, but for the purpose of this video, we are only emphasizing on the achievables. We are only emphasizing on where the marks are. So hence I am giving each one and every one of you a crash course of what to look into, because I know they were done in detail, but maybe some of you still don't understand why the questions change over time. So we'll go to question 4, which is based on organic reactions. So for organic reactions, will also be around plus minus 15 marks. So this is one of the topics that I know for sure that you learners are not getting marks here. And I do not understand exactly why, because everything there is somehow straightforward. So today I'm going to share my analogy with you of key things that you need to look for. So this analogy, you take it into the exam with you, in your mind, of course, not in paper. Then once you get to question 4, you write these keywords down. So once you have written these keywords down, they will assist you to remember. They will also assist you to answer the questions thereof. It says here, identify the types of reaction, addition, elimination, and substitution. Give reaction conditions for each reaction. Identify major and minor product. So I am going to give you a crash course quickly to say when and how will we be able to identify different types of reactions. When is it going to be addition? When is it going to be substitution? And when is it going to be elimination? So imagine us having this guy who is seriously searching. That is triple S, who now went to USA and met a beautiful lady called Sue. So write this down, and after writing this down, it will say to me, if I am moving from saturated to saturated, I am talking about substitution reaction. If I am moving now from unsaturated, the U, to saturated, it means now I am talking about addition reaction. If I am looking at saturated to unsaturated, it means I am looking at elimination reaction. So these are keywords, analogies that I am using for me to remember when I'm sitting in an exam. So I am looking at this single and seriously searching individual who went now to the United States of America and met a beautiful lady called Sue. But it's just an analogy for me to be able to say, if I am moving from saturated to saturated, then I am talking about what? A substitution reaction. If I am looking at unsaturated to saturated, then I am looking for an addition reaction. If I am looking for saturated to unsaturated, then that reaction should be elimination. So this is a way of me saying how best can I remember everything that is given. But now the issue of when is it saturated, when is it unsaturated, it goes back to the first pillars that we started with. Because now if I don't know when is it saturated and when is it unsaturated, then everything thereof is going to fall off. So I won't be able to identify saturated, unsaturated, saturated, and unsaturated. So it means the key pillars that we started with are now building up to different concepts in organic molecules. So it says now these pillars that we started with, if I am able to say something about unsaturated, I am able to identify what is an unsaturated hydrocarbon. It's easy now for me to apply this. So this is going to help me to identify the reactions, because bullet number 1 says identify different types of reactions: addition, substitution, and elimination. Further go on, and then it says provide or give reaction condition for each reaction. That is where now we lose more marks as well. So I will write it as number 2, and then I will say reaction conditions. Reaction conditions. We lose a lot of marks here as well. So remember, this guy who was single and seriously searching went now to the United States of America and met a lady called Sue. So once they are in a relationship with Sue, they decided now to have these 4 children. Their names will be given later on the later stage. But what does this say to me? It says if I am talking of concentrated, then that reaction must be elimination. If I am talking about dilute, that reaction must be substitution reaction. So if I am given a reaction and then I have identified that reaction, it's saturated to unsaturated and it's elimination. So whatever condition that I am going to assign it to, it should be concentrated acid and other things. Concentrated goes hand in hand with elimination. If I am looking at now triple S, the saturated to saturated and its substitution reaction, automatically it says I must use now a dilute base or a dilute acid, thereof it must be substitution. So this way I am not going to confuse anything along giving the correct reaction conditions. One other thing is on reaction conditions as well. It's this one of heat. So you have strong heat and then you have mild heat. So if it's mild heat, it goes hand in hand with substitution. So once I have identified that I am going now to use a dilute strong base for substitution, then the other reaction condition that must be given is I must use mild heat. If I have identified that the reaction is elimination and I am going to use now concentrated sulfuric acid, the other reaction that follows should be strong heat. Can you see that? Because strong now goes with eliminate. Elimination. It goes hand in hand with elimination. So it makes everything quite easy for me to remember in an exam. It's just an analogy that if I get into the exam and write this down, then I will know how to identify each and every reaction that is given. If I am able now to look into the reaction condition and then I write my CEDS, it's easy to say when I talk of concentrated, it goes hand in hand with elimination. When I talk of dilute, it goes hand in hand with substitution. If I look into heat now, which is another condition, a reaction condition, if it's strong heat, then it must be for elimination. So the key idea here is, first things first, let's identify the types of reactions we have. Is it substitution? Is it addition? Is it elimination? Once that is the case, everything becomes easy for us to be able to identify that. But the examiner also says, or under achievables, identify major and minor products. So for us to identify major and minor products, it means we must apply now. Apply Markov-Nikov rule. You must apply Markov-Nikov rule. You will not be expected to state Markov-Nikov, but the application thereof. So the analogy that we use for Markov-Nikov is the richer will get richer and the poorer will get poorer. So the richer are the ones who have more hydrogens. So it means the hydrogen will go to a carbon that has more hydrogens. That is the Markov-Nikov